Welcome to Robots in Depth. Today I'm here with Paul Ekas from Robotics, and we're going to talk about robotics in general, but also specifically about the robotics hand he's developing. So, welcome to the show. Could you start with a short description of your hand here?
Okay, thank you, Per. I've been developing the Robotics EZGripper for the last couple of years, gone through a variety of iterations. This has some unique capabilities. It is very easy to operate. You put it onto an object and you tell it to close, and it will hold that object and not drop it. And it can be in an unstructured environment, so it doesn't matter what kind of object it is. It is also designed to be super low cost. So when I look out 20 years, this architecture, the intent is to have it be the lowest cost architecture for a very long time, and a platform to build on. So that is the EZGripper, and it has been introduced in the last few days.
Yeah, we're here at ICRA 2015 in Seattle, and we'd like to thank the IEEE and the organizers for providing us this space and all the assistance they've given us. Could you tell us, you talk about low cost, you talk about architecture, could you give me the key points that you focused on to bring about this low cost and making it a platform?
Okay, great. So when I looked at grippers in the market, my desire is to have grippers do something like dishes. I don't want a robot friend. I want a useful robot that gets stuff done. I wanted a robot that could stick the hand into the dirty water and do that every day at a very low cost. So to achieve that, I looked at the types of hands that could be built, and about half of them are tendon based, half have the motors integrated into the joints. Having motors integrated in the joints requires a lot of complexity and miniaturization, has reliability issues, and if you plunge it into water, it has some risks. So I like the tendon based. The human arm is tendon based, so pursued that. A challenge in tendon based robotics is wear. And so there's a variety of patent pending technologies in this, but one of the core patent pending technologies that differentiates this from all other tendon based hands and grippers is I'm running Dyneema, which is common, but I'm running them through super hard ceramic eyelets. I'm using aluminum oxide here, which is the same material as sapphire face of your watch. So that allows to have a low-cost architecture that is very high reliability and many cycles. So that's an aspect of it. Second aspect is I am using plastic for building this. This is 3D printed with SLS, but it's all been designed for injection molding. So the fundamental cost structure of this in volume production is very low. And so it's been designed for easy assembly, easy manufacturing, easy repair, and just dropping the cost structure both from the purchase price and the maintenance price.
Because if you open up with a lower price, you really reach new markets that doesn't have the ability to pay what you have to pay today for a gripper.
Yes.
Which can be a lot of money.
It can be a lot of money. A lot of the grippers, and if you're in the robotics and you see some of these beautiful grippers put out there, they got lots of fingers, lots of dexterity, really research oriented. This is designed that you put it on an object, it conforms to the object, picks it up without hassle, because the challenge in gripping with robots is getting the grip to the object. That's at the ICRA, they have the Amazon challenge, and the best teams in the world, getting the gripper to the object is a major challenge. When it's there, it ought to pick it up, grip it, not let go until you want it to let go. It should be easy to use, and that's what I've designed into this permutation of grippers.
Yeah, and also if it's also built to be serviceable, because that's of course also very important.
Absolutely.
That you can actually maintain it. And you talked about it being suitable for a non-research environment. You're talking about doing the dishes and having it in dirty water all the time.
Yes.
Could you talk a bit about the considerations you had to do to make it operate in those kind of conditions?
Well, it's interesting. So the architecture has received interest from space, where it's incredibly lightweight, to undersea. where it's the materials all work very well for it. And it works across there depending on the type of motor put in. And this is a winch-based motor on the system, so you can really put any kind of motor in there to deal with that. So dealing with dirt, you want it to be able to drain, not have any things in it that really are dirt sensitive. It does have bearings in the joint. They're sealed bearings. And if you're in different environments, so say you go to space, you don't want the lubricants of the bearings, so you go to ceramic bearings, readily available, all the sizes associated with this. Same thing with undersea. You can literally put it in chemicals, rinse it off. I can take the motor off, which is designed to be removable easily. I can put it in the dishwasher and wash it.
That also opens up food preparation. It
Yes.
opens up medical fields.
Yes.
So, have you looked into anything of any opportunities in making this sterilizable for medical fields?
I've researched some of it. They use some amazingly wicked chemicals on there. And the fortunate thing is the technologies I'm using in here are all capable of dealing with those types of chemicals. The weakest thing I'm using from a chemical perspective is nylon. Now this can be fabricated out of any material. I've actually submitted it for fabrication in titanium. It was 1,000 times more expensive.
But if that's your application, it's probably cheap anyway.
Yeah,
right?
and if that's needed, it can be done. But the Dyneema actually is incredibly chemical resistant. You can stick that in nail polish remover and it won't dissolve it. The bearings, if they're made out of ceramic, don't care. All the metal's stainless steel in it. So it really is fundamentally chemically resistant design, except for the mold of the hand itself, which can go in any direction based on the customer's needs.
Yeah, so it can both be cheap when it needs to be, and it can also be durable depending on the environment.
Yes.
Is it chemical? Is it depending on the chemical environment?
Yep.
But still to be reasonably low price.
Yes, absolutely.
Yeah. Have you done any gripping tests? I mean, this is a gripper. It's got to grip things reliably. It's got to perform this task. Could you tell us a bit about metrics around this?
Well, gripping metrics is an interesting space. At the show, I was approached by NIST. NIST is doing they're starting a major project which is actually around grip strength. And when I demoed to them the capabilities that I had, they wanted me to participate. Unfortunately, I'm going early from that. But it's going to be a long-term thing, is how do you measure grip? Because what people found at the show very exciting about what I have is I can grab an object that is multiple kilograms wide, I can lift that, maintain it, but at the same time, it can go right around your arm, grip it with the same strength. And I've been actually gripping a banana and not damaging it. And so it's the style of grip that I'm able to achieve with this is actually really a soft, firm grip. Now, how do you characterize that? Right? People have been using parallel plate grippers, and they say, how much force can it put on? It has to put on a lot of force because it's not necessarily using good technique to grasp something. So it's measuring grasp capability is an interesting challenge, and the government's actually funding something to deal with that.
Very
so I look forward to working with them on that and
Yeah.
Characterizing what I have within that context.
Yeah, we're seeing, if you hold it up a little bit higher, we see this, and it's about the size of a human hand. Is it also scalable? Could you do it in different sizes?
So the patent, the pending patents, have the point of view on this that it is really scalable to any size structure that's using links and joints, whether it's a quadruped or a humanoid, or for doing legs in the medical space, might be for actuation around ankles. So it's a very scalable technology from that perspective, and has a lot of value in there. I've focused this on the hands because the challenge that you have in hands that you don't as you scale up is space. You don't have a lot of space to work with. Putting little tiny motors in the joints isn't very easy. As you get bigger, it's easier to deploy potentially other technologies that are more suitable and just moving motors to joints in many cases.
Yeah, so you would use this in this size and down rather than this size and up.
Yeah, there is an application for this in a larger size, and I like to refer to this as a vision that I have called the monkey robot, right? Which is a four-limbed robot, but all the motors are pulled to the core. Now, why is that good? because it makes your inertia centered into the robot. And so let's say that you have a robot that's servicing satellites and it crawls on the outside of a satellite. You don't want to have big weight moving around when it's moving its arms. Also allows it to move arms more easily without the inertia, and it can hold its arm out with less supporting weight. And that's a challenge in robot arms because this is hard. And so they have weight limits of what they can carry because they're carrying a lot of weight in their motors. So there is value in having it in the right types of systems. It's not everywhere, but it has some real advantages potential when we get the smarts to build monkey robots that do useful work in unstructured environments.
So is this available now?
It is available now. Yeah. So I just released this to the public 3 days ago. I had the great opportunity to be at ICRA in Seattle with Robotis. So I reached out to them. I'm using their motor in the gripper. The motor is a Dyneema MX64, which has lots of power. I underutilized the power for reliability. I reached out to Robotics, explained what I had, and they invited me to the show and have taken great care of me. It's been a huge opportunity for me.
Yeah.
And then at ICRA, we have kind of the top tier of robotists who come and give feedback, and I've had a very exciting reception. So it's been great for me.
Any comments you've had from the people attending that you'd like to share?
Well, the people's reactions are very positive, which is great. They like the simplicity, right? It's a very simple design, which achieves the objectives that I want. They're very surprised, right? They see this thing, it looks like a gripper out there, and then they start picking stuff up with it. They can pick up a pen on the table, or they can pick up a liter bottle of water and shake it. It conforms to different shapes and sizes. I think it's when people start interacting with it, they enjoy it. And then I often have people grip their arm and they can feel the grip, and they're very impressed by that. But one of the funniest ones, I have the gripper on a battery system, so I can easily grip things and people can hold it and try it. Two guys walked up, I showed him this thing, handed it to him, he turned to his friend, stuck it right on his friend's face and grabbed his face. Didn't ask if it would be safe or anything.
No.
It is safe. It's human safe, but that was pretty funny.
Yeah. And you should probably check with the designer before you grip somebody's face. Yeah. If it fails, we don't want to be there. That would be horrible.
Yeah, so we're not recommending that, but it was fun to watch.
Yeah. And could you put this in context? I mean, you're operating in the robotic space. Which kind of robot do you see this being attached to, and what will that robot do for someone?
All right. So I've got a variety of visions of robots out there, and we all do because we've seen Hollywood, right? But I've had a great friend of mine died of ALS, right? A brilliant guy, and he's in his wheelchair towards the end. And if he had a robot gripper on the end of a robot arm that could be doing useful work for him, which I think we can pull that off. And it needs to go out and grasp whatever is being desired and bring it up and work with the person in a safe environment. So I see on the medical side that this can actually really add some great value, and I love that. It feels good, and that's fun, right? It's great to talk about. I see at the extreme end of the business potential is stuff like the Amazon Challenge, right? They have an incredibly structured environment, they have all the data, they got the compute power, and they have a lot of pick and place, and this is a perfect fit for that. It doesn't take, get the gripper to the target, a hard problem, and when it grips, it holds it, doesn't let it go, and it puts it where it's supposed to go and doesn't let go, and it lasts for lots of hours, and it's cheap to operate, right? That's significant business for robotic arms. And then the vision that is, I'm a lazy guy. I never worked so hard to automate everything, but doing dishes, right? Folding laundry. That is just useful stuff to automate. It is very hard to do. And as robots get better at working in unstructured environments, doing unstructured tasks, that'll be an amazing set of products that can be brought into human society, and people will buy them like crazy and never think twice after they've got them how wonderful they are. Someday,
Yeah, absolutely.
someday.
And you're saying that you want to do this low cost. Could you tell us anything about the cost right now and how you see the cost developing over the coming couple of 3 to 5 years?
I'll be a little careful about that.
Mm-hmm.
But the design intent from the very beginning is my background, semiconductor industry, right? Relentless cost reduction and value increasing. And so when I looked at the robotic manipulator space, I said, if I'm starting a company to do robotic hands, manipulators, in 20 years, how do I have a cost advantage? And it's not that it will take 20 years to get there. I am right now, I think, by far the most capability at the lowest price of a robotic gripper, and I can see that architecture maintaining its cost competitiveness for 20 years. Right? And so how do you do that? You make sure that the materials you use are easily sourced, that the assembly of those materials is easy to assemble, and the cost structure is, of all the different parts of it, is low cost. That's how you make a low cost product. You design for low cost.
Could you mention a price that if it cost that 10 years from now or 20 years from now, you'd be really proud? That's kind of the high-end goal you have when it comes to cost?
Well, okay, I'm gonna do a couple of things for you. I'm gonna put one direction and then another direction, right? So what I've got right now is the electronics are all in the motor. And there's not a lot of sensor technology out on the hands. That sensor technology is going to evolve, and there's tremendous opportunity there, and that's going to go down in price dramatically. And that's a huge evolution that can occur along there, and I've got a great background to be driving that at a corporate level. The rest of this is it's a box of Legos, right? I've got Dyneema high strength line in there, but that's essentially fishing line, right? It's already a commodity. I've got the ceramic technology in there. I won't go into detail on that, but it's not an expensive thing. The plastic injection molding is a box of Legos, and it's got bearings in the joints. It's got bolts that assemble it. It's been designed for easy assembly. So I won't give you a cost target, but it's a box of Legos, right? For a robotic gripper that can do amazing things. So like I said, in 10 years, can I maintain the price? Well, if the market goes down in the pricing, then it's enabled by the technology that I've got. And the goal is that the hands are ubiquitous, right? That they are everywhere, and that there's a market that allows the price to go down and maintain a very strong business. And this technology can ride that wave.
Yeah, so have you mounted it on any robot? And what if there's a researcher out there that's saying, would this fit my robot?
Yeah.
What kind of sizes are we talking about that you would be comfortable putting it on?
Okay, that's a great, a variety of questions, so I'll answer different pieces of that. So the first robot that I've mounted it on is from Robotis. They reached out, I said I need a robot arm, it'd be great at ICRA, and they just sent me a robot arm. Just huge opportunity.
Yeah, they are a great partner.
Yeah, just amazing. So then I'm using the Robotis Dynamixel MX64, and the beauty of this product in the robotics market is almost everybody in the research community and who works with robots knows how to program these. They're easy to do. So it's very adaptable into other robot systems. The only thing that really needs to be brought together to hook into other robots is a flange that goes from this servo to those other robots. I'll have an open source reference design for the mount that goes this direction, and they can 3D print something that goes to any robot. The second thing is voltage conversion. I have voltage conversion circuits that go around this, and then if you can use the Robotis control for this, which is RS485, so highly reliable, standardized across a variety of different systems. It's easy to integrate in there. So early on, what I'm going to be doing is engaging with customers around their robots and just building the interfaces to that. It's not difficult to do, and it just something will be driven by customer demand. So
the size of robot we're talking about, what's the smallest robot you'd be comfortable putting it on right now?
Well, that's a great, so So let's look at a robot arm, right? A robot arm is at some distance, it can carry some weight. And there's the big evolution of robot arms from huge industrial robots to now we're getting to these very small robot arms with that are safe around humans, etc. They have limited capacity for lifting stuff, and call that anywhere from 2 kilograms to 6 kilograms, right? That's a reasonable range to have the discussion.
We haven't mentioned the weight of it.
Thank you. And a key point is when the robot gripper is on one of these robots, it's consuming that capacity, right? So if you have a 2 kilogram gripper on a robot that has a 2 kilogram capacity, you can do zero work.
Yeah.
This is 350 grams.
Yeah.
It's ultralight. And so that allows it to go on a range of robot arms that are smaller than most competitive products out there.
And still have a useful payload that's significant.
Exactly. And then so the question is, as you go up to bigger and bigger robots, how long is that still valuable? Well, the biggest robots I'm seeing at this show, right, are that are working in these kind of environments are things like the Baxter and the UR5, UR10s, etc., which are very capable robots. This is more capable of lifting larger objects than their standard grippers that they come with, which are generally little pinch grippers, and it can integrate nicely into those bigger arms and have plenty of payload capacity for them.
So anything you'd like to close with? Any points we haven't mentioned for somebody interested in the hand and utilizing it?
Well, number one is we put up the website a couple of days ago, so brand new, SAKErobotics.com. It's a developing website, developing product. We can deliver product in about a month to customers, looking for early customers to engage. You heard all the value propositions in there, and I'm excited about going forward and meeting customers, understanding their applications, and being responsive to their needs in developing this technology forward into the robotics market.
Yeah, perfect. And thinking I love anything low cost. I love anything that's kind of modular, and getting more robotics into the hands of more people to be able to experiment and develop things. So very interesting. Thank you for taking the time to do an interview, and I'll hope to hear lots of interesting applications from you in the future.
Thank you, Per. This has been very good for me, and I appreciate your opportunity to do this.
This episode is sponsored by Aptomica. Everything you need in modular robotics. Or robots up close, what's going on in robotics, online and on the road. If you like this interview, don't forget to subscribe, follow us on Twitter, and subscribe to our email newsletter on robotsinDepth.com.